cosines. So you have the integral of sine to the n of x times cosine to the n of x times dx. We have two cases. Case number one is if m or n are odd numbers. If that is the case, you have to use the identity of sine square of x plus cosine square of x equals to 1. And the other case is if m and n are even numbers. You have to use the identity substituting sine square of x equals to 1 minus cosine of 2x over 2, or cosine to the square of x equals to 1 plus cosine of 2x over 2. We have the first example of the case number 1 is the integral of sine square of x times cosine to the 3 of x times dx. First, you have to separate this because this is an odd number, so you have to use the formula of the case 1. Is sine square cosine square of x times cosine of x times dx, and then substituting this formula in the integral. And then do this product. And then if you use u is equals to sine of x, and du, that is the derivative of sine, is cosine of x times dx. So you use u squared times du, that is cosine of x, minus the integral of u to the 4 times du, and then you have to do the integral of u, that is u to the n minus u to the 5 over 5, and this will be equals to sine 2x minus and you get the result. And another example is of the case number 2. We have the integral of sine square of 3x times cosine square of 3x times dx. As we have even numbers in the product, we have to use the formula of the case number 2. We have to substitute those values with the formulas. We write the constants out of the integral sign, and we make the product of it. Whereas we have another even number here, we have to use again the formula of the second case. We make the product and we write the constant out of the integral sign, and we have dx minus cosine of 12x times dx. And we have the integral of dx is x, and we have the result.